Okay, 4.3, solving polynomial inequalities. All right, a little bit of a more challenging one here. Okay, for these, we have to know in order to solve, well, we can solve them, but after that, we need to use a graph. And from the graph, we'll be able to help us solve the inequalities. Okay, so if we kind of went through this the other, or a week or two ago, with regards to the end behaviors. Okay, so if we have a leading coefficient that is positive, a linear equation would look like this. Okay, I'm going to do the odd ones first. It would look this way. If we had a cubic function, it would look like such. And if we had a quintic function, it would be the same thing. Okay? Please note the quadrants that the odd functions are going through. Okay, they're going through 3 and 1. So quadrant 3 and quadrant 1. If we have a negative leading coefficient, then it gets reflected over the x-axis. So then what happens is your linear equation goes downwards, your cubic goes into the other two quadrants, and same with your quintic. Okay, so positive leading coefficient, we have quadrants 1 and 3. If it's negative, we have quadrants 2 and 4. When we do the even functions, so a quadratic, we have something that looks like this, and a quartic function looks something like that as well. If you have a negative leading coefficient, so right now it goes through quadrants 1 and 2. If we have a negative leading coefficient, then it gets reflected over the x-axis. Okay, so we have a value going like such. Okay, so it's very important that you understand the quadrants that each of the functions go through, whether it's odd or even. So if it's odd and positive, it goes through 1 and 3. If it's odd and negative, it goes through 2 and 4. Always opposite. Odds always go in opposite directions. See, opposite quadrants. Okay, when we had even functions, positive goes through quadrants 1 and 2, so same directions for the end behaviors. And then we have, for a negative even function, we have, it goes down through quadrants 3 and 4. So to solve a polynomial inequality, this was I was just saying, we must have an idea what the graph will look like. The most useful form of a polynomial function is in factored form, because we could get the x-intercepts in there and then we could draw, where we can identify the x-intercepts and the leading coefficient. Okay? Okay, so, So number one, solve the following inequalities. So again, we just want to know what the x values are. Okay, so this one we already have it in factored form, so we just need to know the x values. Okay, so here, so the x values, so we know the x-intercepts, so then we can then solve it. So our zeros are 2 and 3. So our zeros are 2 and 3. Okay, so why do we need that information? Well, if we have a graph, we have our intercepts at 2 and 3. So pretend this was 2 and 3. Okay, so here we have two x's. If we were to multiply them together, you get an x squared. So we have a quadratic. We have a quadratic. So we want to know what values of x will be greater than 0. So what values of x can we plug in here that will give you an answer greater than 0? Okay, so what happens is if it's a quadratic and it's positive, that means it's going to go up this way. So it's going to come through the x-axis here. It's going to turn and then go up the other way. Okay, so the question asks, again, what values of x can we plug in here that will be greater than 0? Well, this arm here is greater than 0, and this arm here is greater than 0. So the values that are make it greater than 0 are everything less than 2. So x is less than 2. Okay, and then over here we want, so everything greater than 3 will give you positive answers. So x is less than 2 and x is greater than 3. Okay, see how this has a greater than? We don't have to put the equals to. So less than 2 or greater than 3. Okay, B, x cubed plus 2x minus 5x minus 6. Okay, so this one was already in factored form. So now this one we have to convert to factored form. Since we have a cubic function, rewind. Every time we have to factor, we want to look for something first, and that's for a GCF or greatest common factor. Well, there isn't one here. Okay, so we need to factor it. In order to factor it, we need to have a factor. So we have to find a factor of the last number here, which is 6. So our factors are 1 and 6, and 2 and 3, plus or minus for all of them. So substitute into the equation, okay, and find out which one will make you 0. I have already did this, but let me just double check this. I'm going to plug in positive 2. So I get 8 plus 8 minus 10 minus 16. So 8 and 8 is 16. Negative 10, negative 6 is negative 16, so that equals 0. Okay, so positive 2 works. So positive 2. So we're going to use a type of division, so you can do long division or synthetic. Personally, I like synthetic, so I will use that one. So we're using positive 2 is our value. So we have 1, 2, negative 5, and negative 6. Bring down our 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. Okay, so therefore we have our first divisor or factor, which is x minus 2, and then x squared plus 4x plus 3. So we factored it once. So we factor out an x minus 2 from the equation. Now we're left with the quadratic. This is a simple quadratic since there's a coefficient of 1 here. So let's break this down. Two numbers that multiply by 3 that add up to 4, and that would be positive 1 and positive 3. So x minus 2, and then we factor this as x plus 3 and x plus 1. 3 times 1 is 3. 3 plus 1 is 4. So therefore, our x-intercepts are negative 3, negative 1, and positive 2. So 2, negative 3, negative 1. Okay, but that's if this equation had an equal sign. If it had an equal sign, then this would be our answer. But we don't have an equal sign, we have an inequality. So we want to know values here. What values are less than or equal to 0? So again, let's look at our graph. So going through our graph, we have negative 3. So negative 3, negative 1, and positive 2. So our x-intercepts are here, here, and here. So negative 3, negative 1, and 2. So we know it's a cubic function, and we know that it's positive. Okay, so our end behavior is going to be in quadrant 3 and quadrant 1. So this way and this way. We also know, going back to last chapter, that these have an order of 1. So if there is an order of 1, that means it crosses through the axis, okay? Doesn't touch it, it goes through. So here, we're gonna go up through -3, down through -1, and then through +2, okay? It's just a rough sketch because we don't need to, we don't need to know exactly where these local maximum are. We just wanna do a sketch so that we can answer our question. So again, the question is, what values of x are less than or equal to 0? So here, less than or equal to 0, 0 being the x-axis. So we have this part is below 0, and this part here is before 0. So x values that are less than or equal to -3. So x is less than or equal to -3. And x values that are between -1 and 2. So greater than or equal to -1, but less than or equal to +2. And you'll notice that I put the equals to, because in the question we have the equals to. Okay. We're going to move on to our last question, I think it is. Okay, but remember here, sorry, I forgot to say, if you can't factor it, use the quadratic formula to find the x-intercepts. Oh, sorry, the last one was right here. Okay, so sometimes you'll have terms on both sides of the inequality. So just what we want to do is bring everything to one side from there so that we can factor. Okay, so we are going to subtract 16x from here on both sides. And we're going to add 8 as well. Just remember that you only change the inequality sign when you are multiplying or dividing by a negative. So we get x cubed plus 5x squared minus 14x, and then this crosses off, so 0, which is greater than or equal to 0. Okay, so now we are going to factor. Again, the first thing to do always is to look for a greatest common factor. So here, in this case, they all have x's. So we're going to factor out an x. So x squared plus 5x minus 14 is greater than or equal to 0. So now we're already into a quadratic. So we're going to factor it to numbers that multiply to -14 and add up to +5. Well, that would be +7 and -2. So 7 times -2 is -14. 7 minus 2 is 5. So therefore, our x-intercepts are 0. Sorry, I'm going to go in order. -7, 0, and +2. So +2, -7. Whenever you have the x by itself, it's 0. So again, on a graph, we have intercepts of -7, 0, and +2. We have a positive leading coefficient, so it's a cubic function with a positive leading coefficient. So our n values, our n behaviors are going to be the first and third quadrants. Okay, now we just, since these are all degrees of 1 or orders of 1, we're going to cut through the x-intercept at each of those points. So something like that. So the question asks, what values of x will give me an answer greater than or equal to 0? So we have this part that's greater than 0, and this part that is greater than 0. So that is from -7 to 0, and then from 2 onwards. So x is greater than or equal to -7, but less than or equal to 0, and x is also greater than or equal to 2. Okay, so that is the that is the lesson for 4.3. It's also the last lesson for the chapter. Okay, so homework is here. Ooh, that's supposed to be number 2 and 5. 2 and 5, and 6 AC, 7 AC, 6 ace, 7 ace, ACE, 8 and